Hello, it is 2:39 a.m. Our little hackathon team is we're really having quite a wonderful time here at ETH Barcelona. We have been hacking on a way to release the record that we recorded in Nashville, Tennessee, in the United States earlier this year. We want this record to be free and unencumbered, to be Creative Commons, but we still want to recoup some of the costs of recording it. So the plan is to encrypt it using Threshold Network condition-based decryption, and then we'll have a smart contract. The condition will be that 10 ETH go into that contract, and then the record can be decrypted. And so I want to show how that works. I think it's very interesting cryptography and a very interesting cryptological system into which it fits. So I just want to give a quick rundown of how this hack has gone. We encrypt the song, a song, symmetrically. Presumably, I'll encrypt each song on my album individually. We have until at least tomorrow to figure that out. But in this case, I'm encrypting a little bit of Manzanita by Tony Rice, which is, I think, one of the most beautiful pieces of bluegrass guitar ever put to recording. I honor Tony and his legacy every day. We encrypt this symmetrically, fairly typical process here using Fernet. And you can see that we're going to take the plain text of the symmetric key that was used to encrypt that. This is what we use. This is what we encrypt using the Threshold Network as the plain text of the symmetric key. Then we're going to take the bulk ciphertext. That's the encryption of the actual song. Again, in this case, Tony Rice, but in production, it'll be a song from the record, each of the songs individually from the record we recorded, perhaps also the full record itself. We've got to kind of look at all the ops particularities there. And then we have a Discord bot at the other end that I'll show at the end of this presentation that is able to decrypt this bulk ciphertext, get the resulting music file, which in this case is an MP3, but in the real world we'll use FLAC, obviously. And it's then able to post that embedded in a message so that you can listen to it on Discord, even though it's encrypted up until the moment when the condition is satisfied. So again, up here, this is all very typical, just symmetric key encryption. This is the part where the thresholdy stuff, the interesting part, begins. This is our section where we invoke our character Enrico, who lives in the threshold code base. We have Alice and Bob, like in the traditional cryptographic narrative, and we've also added a few other characters to reflect the threshold cryptographic concern that power is distributed in different ways with threshold cryptography than in ordinary public key cryptography. Here we have, this is basically just a little bit of housekeeping to look up the distributed key generation ritual that's already happened. So think of this as sort of boilerplate for the moment. Here's the Enrico that we instantiate. Some debugging stuff here, and then here's our condition. We're checking that the balance of a given address happens to be 0. We just picked a condition we know to be true, to test out the Discord bot, right? So here we encrypt the symmetric key, and again, this we're encrypting for a DKG, or it's kind of odd phraseology, but we're encrypting for a cohort that has previously engaged in a DKG to produce a public key. So this is the really interesting part of what Threshold Network is capable of doing. And from that, we get the ciphertext of the symmetric key. And here we build, I just named this really quickly, a Threshold Message Kit, TMK. I'm not usually one for abbreviation, but I was getting tired. We include the bulk ciphertext and the encrypted symmetric key. So, of course, if you had the decrypted symmetric key in this, you'd be able to listen to the song. We include the conditions, and we include a file name, which may seem a little odd, but actually this is really only because Discord wants to know the file extension in order to know how to embed the file. We probably will hide that and make it a little easier for the user to just use the initial file name if they want. So here, quick sanity check, just make sure the thing we hope is Tony is actually Tony, just to make sure we've got the correct encryption here. And then that's really it. We're going to make a file called tony.thresholdMessageKit, and we will write the JSON metadata, which again includes the ciphertext and the encrypted symmetric key. and then that can be posted to our Discord channel. So I'll run this. All right, you'll see it does have to do some network I/O. That's actually possibly optional. You could cache that yourself if you wanted to, but if you just sort of use our APIs the way they're designed, it does a quick bit of network I/O to go get the public key for the cohort, because that's known and on chain. And then, yep, here's Enrico doing what it does best, which is encrypting this symmetric key. Cool. It wrote these bytes to a file. Great. There's the file, and I'm gonna hop on over to Discord and drag that file into Discord here. We just had it go right to the root of the project. Drag that there. Okay, and then nothing happens at this moment. Instead, what happens is make sure that the Discord bot is running. What happens here is that once that message is posted with the Threshold message kit, you can reply to that message and say decrypt. Probably will force you to tag the Discord bot, because it'd be a little weird to just reply without saying who you're asking to do the decryption. But again, long day. It is 2:46 in the A here. I'm just going to say decrypt, and that you can see the revealer bot says, okay, I'll try to see if that can be decrypted using Threshold Network. And here it's going to give us a little bit of log output. It doesn't take too terribly long. The vast majority of the time it's the network I/O. There you go, and you can see it decrypted it, found the original MP3, posted it here as a message. 10 seconds of Tony picking for you. And that's really the long and short of it. The only other interesting part that you might want to look at, I mean, there's many other interesting parts, but the only part of this particular end-to-end process that I've just shown now that is probably somewhat surprising is here when we parse the message and instantiate our Bob character. That does some pretty wacky and interesting and pretty hardcore cryptography that we're really proud of. We've at Threshold Network, we've been working for a long time to empower hackathon use cases just like this one, and so the fact that we were able to put it together in just 2 days in a hackathon time frame is very, very exciting. Yeah, that's really the end-to-end of how it works at this moment. I have 7 hours to decide the particulars of the contract and how I'll encrypt the songs and these sorts of things. So yeah, this is very exciting. To our knowledge, this is the first time that Threshold cryptography has been used in this way to facilitate the publishing of something that then becomes free to the world. And I think it's an interesting way to publish free music, but still ensure that musicians are able to get paid. That's become a bit of a passion of mine, enough so that I've kind of that I've followed that pursuit with my own music to see if it can work well. And yeah, I'm way beyond my record. I'm very interested to see how this is used. It doesn't have to only be music. Obviously, this extension here, if this were a .jpeg, this would embed the image and so on. So it is potentially useful for a number of applications, even beyond art. But we're sort of initially tailoring the bot for creative pursuits, and yeah, we're interested to see how it gets used. So yeah, that's the end-to-end of the bot. Feel free to jump in here in the Justin Holmes Music Discord to follow our progress. I feel so blessed that people are taking an interest in my music. I have been working very hard on it over the course of the last year. I have a wonderful little crew here in the Discord, and we've made crazy progress in the past 2 days on this tech. So yeah, thanks for watching, and thanks for considering our submission.